Hi everyone, I'm Dr. Darcy. Welcome to my class. This video series is all about precalculus. As the name suggests, precalculus is essentially preparation for calculus course. If you look closely, all the maths we learn in middle school and high school, whether in the domestic or international curriculum, actually lays the groundwork for university level mathematics like calculus and other fundamental math subjects. The analytical methods for various functions you will use in calculus, such as those for linear functions, parabolas, logarithms, exponentials, and trigonometric functions, are all covered in this precalculus foundation. This goes with the algebra components that are heavily emphasized in middle and high school curriculum. If you follow closely with this entire video series, you will find yourself gaining a whole new understanding of mathematics. Furthermore, you will be well prepared to successfully watch my next series, Calculus. And after that, we can move on to linear algebra and probability or statistics. If you develop a deeper interest in math, you can entirely explore other courses that I offer online, like functional analysis, studies of imaginary numbers and components, and complex variables. I'm open to discuss all these fundamental math topics based on your interest. And of course, if you're a teacher yourself and want to share teaching methods with me or want to discuss teaching methods with me, I'm more than happy to share my established teaching system, results, and style with you. If you have other interests or just want to connect, you're absolutely welcome too. All right, so let's just dive into the first key concept of our precalculus journey, the coordinate system. This is a topic typically introduced in the first year of middle school. The coordinate system is also known as the Cartesian coordinate system. So, who was Descartes? He was a French mathematician. Why did he invent the system? Well, story has it, this is from biographical anecdotes that one day, while he was taking a bath, he had a sudden idea. He looked at objects like an apple and a banana and wondered how I can precisely determine their positions. He realized by using his own position as a reference point or origin, he could describe locations. For instance, the apple might be 3 meters away horizontally and 1 meter away vertically. So he would make the position of apple as 3, 1, making him as the origin. So with this reference system, he could describe other things' locations. For example, if the banana might be 1 meter away in both directly and vertically direction, he will represent it as 1, 1. The primary purpose of inventing the Cartesian coordinate system was to study the absolute and relative positions and motions of objects. Setting up a standard coordinate system usually involves two steps. First, determining the origin, and second, drawing the x and y axis. For precision, we should also establish the unit length. However, most textbooks only introduce 1, 1 as the coordinate system, explaining that it represents an x-coordinate of 1 and a y-coordinate of 1. So from its introduction, the core aim is to describe position. Later, Descartes also adapted this system for kinematics, introducing the concepts of an absolute coordinate system with a fixed origin at OO, and a relative coordinate system where the origin can move. For example, if I'm walking, the relative positions of all objects to me change, but their absolute positions relative to the fixed origin remain the same. Now let's dive deeper into what coordinate system really means. How do we find a point like 1, 2? We locate the position where x equals 1 and y equals 2. So we can draw two lines here, x equals 1 and y equals 2. So the point 1, 2 lies on the intersection between the two lines, and that's how we pinpoint the location of one point. Think of the coordinate system as resembling a field you might encounter in physics. This system is essentially filled with invisible lines or guides that help us locate points. For instance, to find 1, 1, you can just find the vertical line y equals 1 and the horizontal line x equals 1 to find their intersection. And there are so many invisible lines here. So you can use these lines to help you pinpoint the location of other objects. These guiding lines are implied but not physically drawn everywhere, so we often represent them as dashed lines. It implies that the space is filled with these invisible guides. To find a point, you just follow them. This concept even extends to other systems that we will learn later, like the polar coordinate system, where the space is conceptually circled with these lines and angles. This is called coordinate system, which we will learn in further precalculus. Let's look at the positional characteristics of points with this system. Consider the origin, O, usually denoted as 0, 0. Now take point A as 1, 1. Take point A as 1, 1 and B at 2, 2. What relationship do you see these points A and B? And if I add a point with x coordinate 3 and y coordinate of 3, so there goes another point D. Its x coordinate is 4. So followed this pattern, what will its y coordinate be? It will be 4 as well. So what patterns are there between those points? As you can see, their x coordinate equals y coordinate. So we could express this relationship as y equals x. This equation describes the sets of all points where the y coordinates equals the x coordinate. If x is minus 1, so y is minus 1. If x is minus 2, so minus 1 minus 2 as well. And if we connect them together, we will find it actually represents a straight line. Let's revisit the concept of lines themselves. They exist as fundamental entities. In space, lines are arranged in various ways. For example, Elements, the first book, describes the relationships between lines. In a line, two lines are either parallel or they intersect. This is because if two lines in a plane are not parallel, one extended infinitely, they will eventually intersect under two-dimensional world. This was a fundamental conclusion, so lines already have inherent relationships in space. The power of the coordinate system is that it allows us to express those relationships algebraically. We just need to see that y equals x represents on a specific line. It describes the sets of points where the coordinates are equal. How do we describe other lines? Some other lines that are parallel to this, or some other ones intersected at different angles. This becomes a central question we can explore once we have the tool of the coordinate system. And see you next class.